Hey guys, this is Math Heads 101. Today we're going to be doing solids of revolution. Yeah. So, solids of revolution means rotating a function around a line. So, in calculus, you learn two ways of doing it. You can rotate around a horizontal line or a vertical line, and then later you can figure out how to do a line, any line, not just horizontal or vertical. So this is our f of x. Actually, I'm just going to draw it in the first quadrant. I'm going to draw a simple shape because you really want to be able to visualize this. Okay? Okay, that's f of x. Quarter of a circle. Okay? So, first we're going to visualize rotating around x, and then we'll rotate around y, and then we'll hopefully know how to rotate around any line that's horizontal or vertical. So, what we're going to do, well, first it's going to look like this, and then these are rotated around, right? Okay, so what you want to do is take the value of each function, the value of the function on each point, and rotate that around. Woo! Woo! Okay, so now that's half of that, so you could consider it the radius. Okay, so this is like the area of a circle, and then it has a tiny width. So it's going to be pi r squared, and then tiny width is dx. And then you're going to sum up all of those. So the integral, and then from wherever you want to wherever you want, from a to b. Okay? But what is r? R is f of x. So, I'll keep it as r. Okay, so it's equal to pi times the integral from a to b of f of x squared dx. Okay. Now, focus on that. Understand it. Okay. We're going to rotate around y. Look how big I drew it. Now you have to love it. Okay. So we rotate this around y. Obviously, if you just reflect it around y, it's going to do this. And you're rotating it, so this is going to be like, woo, woo. It's going to give you like, well, if you rotate a quarter of a circle, it's going to give you semicircle, both ways. But now it's going to give you top of a circle, and the other way give you the side of a circle. So what do we do? Well, obviously, we're going to have, okay, so you take the value of 1 point on the function, okay? F of x. Okay? Now you're going to rotate that value around. Okay? So when you rotate that value around, you have f of x times the perimeter of the circle that it makes. So that's going to be, the perimeter of a circle is 2 pi times the radius. So it's 2 pi times f of x, and what's the radius? The radius is the distance from the rotation axis. In this case, it's just x. And then obviously, every time you're going to do, because that's just going to give you infinitely small width. So we're going to add a little, well, that's going to give you no width. We're going to add infinitely small width, or multiply with infinitely small width. Right? Because you can't just do one value, so you can do dx. And every time you do an integral, every time you see in dx, there's probably going to be an integral involved. And then it's just from a to b. Pretty simple. Now, alright, now I'm just going to give you a complicated example. And then from there, we'll see what happens. Okay, we're going to rotate the value between two curves around a vertical line. Also, if you want to rotate a horizontal thing or a vertical thing, you could just switch X and Y and rotate it around the new thing and then switch it back. I don't know if that made sense. Because if you switch X and Y, then you're rotating the function about 90 degrees or pi over 2 radians. And yeah. Anyways, let's say we have, I don't know, what's something I can visualize. X squared and the square root of X. Okay, I'm just gonna go there. Okay, so we have X squared and the square root of X. And this is 1. And that is 1. Because 1 squared and the square root of 1 are both 1. And that's 0. So what are we going to do? We're going to rotate it around -1. Around x equals -1. So for any y, x equals -1. So what's that look like? Well, let's rotate this value. Woo, woo. And then it's going to be symmetrical with respect to that. So it's going to look like this. So your whole thing is going to look like a squash donut. Talking about a lot about donuts in these videos. Lousy graph. A lot of lousy. I'm bad at art. Okay, it's not why. This isn't art videos. If it were art videos, I'd be like, alright, how do we draw a face? Well, you make the nose, and then you want to make it a good nose, and no. There's our face. But it's not art. So, we're not doing that. Anyways, first let's find the area under that, and then let's rotate it around. So the area is going to be the value here, value of that function, minus value of that function. So you're getting rid of that. Value there, minus value there. So which one's bigger? The square root of x is going to be on top. So we have the integral from 0 to 1 of the square root of x minus x squared dx. Pretty simple. Now we want to rotate that around. So when you rotate around, you're going to have 2 pi, that's the perimeter of a circle, times the radius, so 2 pi times the height, and then times the radius. So the radius, it's not there, it's not x, because every time you do an x, you still have like a whole 1 there. So it's going to be x plus 1. So we do an x plus 1. Oh, now we got to evaluate it. That's going to suck. Okay, I'll evaluate it just for you. Okay. So we have 2 pi. Okay, maybe it'll be a fun answer. Times 0 to 1. Now we gotta multiply all that shit out. So we have that guy times that guy is x times the square root of x. Now we have that guy times that guy, that's minus x to the third. That guy times that guy is plus the square root of x. That guy times that guy, so that's minus x squared. Okay, now it's dx. Okay, now let me erase this, get in the way. And now that we have the formula, we don't need the picture anymore. So it's 2 pi times the integral from 0 to 1. And I'm just going to write these terms better. So that's x to the 1/2 times x to the, so it's x to the 1 over 2 times x to the 2 over 2. When you're dealing with exponents and you're multiplying them, you add. So 1 over 2 plus 2 over 2 is 3 over 2. X to the 3 over 2. Okay. Minus, that's still x to the 3. Plus x to the 1 over 2. Minus x to the 2 dx. Okay. Evaluate. Time. 2 pi times that shebang. It's going to be x to the 2 over 2, 3 over 2 turns into the x to the 5 over 2. And you put the reciprocal in front. Okay. Minus x cubed becomes x to the 4th, and you put that over 4. This one. So that's x to the 1 over 2. It's going to become a 3 over 2. So we're going to put a 2 over 3. X to the 3 over 2. Last one. Minus x cubed over 3 between 0 and 1. So this is equal to 2 pi times 2 over 5 minus 1 over 4 minus 2 over 3 minus 1 over 3. Do I feel like simplifying? You know what? I already went this far. Might as well. Okay. Now, alright. We already have a 2 over 3 minus a 1 over 3. I probably made a mistake somewhere, but let's... So it's not... That wasn't 2. So negative 2 over 3 minus 1 over 3. So you have a negative, and then we have a minus a negative, so that brings it more that way. So it's going to be minus 1. We'll just make that 1 a 20 over 20. We'll make the 5. We're going to multiply both by 4. So this is going to be a 20. And this is going to be 2 times 4 is 8. We multiply both by 5. So that's 5 over 20. So that's equal to 2 pi times 8 minus 5 is 3. So it's 3 over 20 minus 20 over 20. So that's negative 17 over 20. Now, what do? We make that a 10. Okay, so the answer is going to be negative 17 pi over 10. I don't know why I wasted my time with that problem, but I did. Thank you for watching Math Heads 101. Subscribe and